Somewhere in southern Oregon, there is a lake that shouldn't exist. It sits inside a hole left by a mountain that no longer stands. A mountain that didn't erode, didn't slowly weather away, but collapsed in a single catastrophic afternoon roughly 7,700 years ago. The lake that filled the hole is 1,943 feet deep, deeper than any other lake in North America. And the Klamath people, who have lived in this region since long before the collapse, have a story about exactly that day. A battle between spirits. Fire pouring from the sky, a mountain falling in on itself. For generations, researchers filed it under mythology and moved on. Then geologists drilled into the lakebed, pulled up core samples, and found the ash layers. And those layers told the same story, beat for beat, that Klamath elders had been telling around fires for thousands of years, which forces a question that is genuinely difficult to answer. How does a people hold on to the memory of a mountain they watched die nearly 8,000 years ago? The account has a name. The Klamath and Modoc people called the spirit of the mountain Lau, and they placed his home at the summit of the peak they called Lau Yaina, the mountain that stood where Crater Lake now sits. His counterpart was Skel, spirit of the sky, whose domain was the peak to the south that we now call Mount Shasta. Two mountains, two spirits, one war. The battle, as the account goes, was not metaphor. Fire poured down from above, Skel striking from the sky, and fire erupted upward from below, Yao answering from the mountain's heart. The people caught between them fled. Some accounts describe people running toward the caldera's edge, throwing themselves in, offering themselves to stop what was happening. Whether that detail is literal or encodes something about the chaos of the moment, the geological record is clear on one thing. People were close enough to witness it. And then Yao's mountain fell, collapsed inward. The fire that had been erupting upward swallowed itself, and where a peak had stood, there was suddenly an absence, a bowl, that the rains and the snowmelt began to fill. Here is where the account becomes harder to dismiss as vague cultural memory. The landmarks named in the Klamath telling are not symbolic stand-ins. They are specific, identifiable, locatable on a modern map, not a mountain to the south, but a particular peak, not a lake somewhere, but the exact basin. Which raises the question, how granular does the memory actually get? Granular enough that scientists found it in the dirt, literally in the soil, in lake sediments, in glacial ice cores, in the exposed faces of canyon walls across 7 states and 2 countries. The ash from Mount Mazama's collapse didn't stay local. It rode the jet stream northeast, and it landed everywhere. A thin, pale layer sitting between the layers above and below it, datable, distinct, unmistakable. Geologists call it the Mazama tephra, and it has become one of the most useful stratigraphic markers in North American geology. Find that layer anywhere in the continent, and you know exactly when you are. 7,700 years ago, give or take a century. The plume reached Saskatchewan. Over 1 million square kilometers blanketed in ash from a single afternoon's catastrophe. The scale of what the Klamath witnessed wasn't a regional event that might have been exaggerated in retelling. It was continental. The ground itself wrote it down. But here is the question that sits at the center of all this. How do you reconstruct the specific sequence of an eruption that ended nearly 8 millennia ago? The order of events, the direction of the blast, the volume of material expelled, in enough detail to lay it beside a story and say, these match? The answer starts with what ash can actually tell you. And it is more than most people expect. Ash tells you what was in the magma, how hot it burned, how high it flew. But to understand the collapse itself, the mechanics of how Mount Mazama ceased to exist as a mountain, you have to read something else. The deposit geometry, the layer sequences, the physical architecture of what got left behind. And what got left behind is staggering. The eruption ejected roughly 12 cubic miles of material. That number is hard to hold. Put it this way. The 1980 eruption of Mount St. Helens, the one that killed 57 people, flattened a national forest and sent ash to 11 states, expelled about 1/3 of a cubic mile. Mount Mazama expelled 40 times that volume in a single event. When that much material leaves a volcanic system that fast, the ground above it has nowhere to go but down. The magma chamber beneath the summit emptied faster than the rock overhead could be supported, and the peak, a mountain that had stood perhaps 12,000 feet high, dropped into its own foundation. Not an explosion outward, a collapse inward. A bowl 2,000 feet deep, roughly 5 miles across, punched into the landscape in hours. What that looked and felt like to anyone standing within range. The sound, the heat, the concussion, is the question the oral record was built to answer. But before we get there, the geology still has more to say. The geology has had its say. Now stand in it. 50 miles out, the first thing you would have noticed is the sky going wrong, a darkness moving against the wind, a smell like struck iron and burning stone. The ash column climbed somewhere between 25 and 30 miles into the atmosphere. At that height, it stopped being a plume and became a ceiling, and the ceiling traveled. Fine ash fell as far as central Canada. Closer in, it wasn't ash, it was rock. Pumice blocks the size of fists raining down for hours, igniting anything that could burn. The ground shook continuously. Not the single jolt of an earthquake, but a sustained vibration, the kind that loosens teeth and makes standing difficult. Pyroclastic flows moved at hurricane speeds through valleys that had been travel corridors, burying them under deposits still dozens of feet thick today. The sound, and this matters because sound is what the oral record reaches for, would have registered as physical pressure, not heard so much as felt in the chest. For a generation afterward, the landscape stayed hostile. Pumice rafts floating on the water that began filling the caldera were still warm enough to burn. Which raises the hardest question: could anyone have actually survived close enough to remember any of this? The answer isn't theoretical. It's sitting in a cave in Oregon, and it has been for roughly 77 centuries. Fort Rock Cave is a shallow volcanic formation about 100 miles northeast of the caldera, close enough that when Mazama erupted, the ash came down like a slow burial. Archaeologists digging through that ash layer in the 1930s found something that stopped the excavation cold. Sandals. Dozens of them. Woven from sagebrush bark shaped for human feet, left on the cave floor before the pumice sealed the chamber shut. Radiocarbon dating placed them squarely in the period of the eruption. These weren't artifacts from later settlers who moved in after the landscape recovered. They were already there when the mountain came apart, which means people were in the region during the event. Not near the blast zone, Fort Rock would have been survivable far enough for ash but not pyroclastic flows. But the pumice that buried those sandals fell from the same column that turned the sky dark across half the continent. So the question shifts. It's no longer whether humans were present. They were. The harder question is what they did next, and whether anything they saw made it into words that outlasted them by 8,000 years. So here is the question researchers actually had to sit with. Do the Klamath accounts match the geology in any specific way, or is this just a loose family resemblance? Fire, mountain, collapse, the kind of broad strokes any eruption story might contain. The principal account, recorded by ethnographer Albert Gatchett in the 1870s, describes two powerful spirits in conflict. Lao stands on Mount Mazama. Skell stands on Mount Mazama. Skell stands on Mount Shasta to the south. The battle sends fire downward from the sky and upward from the earth. The mountain itself is destroyed. The land darkens. And eventually, over time, the hollow fills with water. Lay that against the stratigraphic record. The Mazama eruption was not a clean single blast from the top. Geologists have documented phreatic explosions, steam-driven detonations triggered when magma hit groundwater, and extensive lava fountaining from vents along the flanks. Fire coming from below the ground, not just above it. That is a specific detail. It is not the default image of a volcanic eruption. A later storyteller embellishing from rumor would almost certainly describe fire falling from a mountaintop, not erupting from the ground beneath it. The Klamath description catches both directions, and that specificity is what moved this from folklore curiosity into something geologists and anthropologists found worth taking seriously. The Klamath account didn't survive because someone got lucky. It survived because oral cultures developed something that looks, from the outside, almost like a technology. A set of interlocking mechanisms specifically designed to hold precise information across generations without a single written character. The Klamath weren't unusual in this. Across the planet, cultures without writing found the same solutions independently, and the solutions share a recognizable architecture. Ritual repetition, ceremonial context that makes alteration feel like transgression, not creativity. Specialist memory keepers, people whose social identity is bound to custodianship of particular accounts, and crucially, Redundancy. The same core information carried in multiple independent forms, a story, a song, a ceremony, a place name, so that if one transmission line degrades, the others hold the shape. These aren't soft cultural practices. They function more like error correction. The redundancy is the point. And the Klamath account isn't the oldest verified example. Australian Aboriginal traditions describe coastlines swallowed by rising seas after the last ice age. And researchers have matched those accounts to specific submerged geography. Some of those stories appear to encode events 10,000 years old, which forces the real question, not whether it's possible. We now have enough cases to know it's possible. The question is, how does the mechanism actually work? What holds the words in place when everything around them changes? But not everyone finds that question compelling, and their skepticism deserves a fair hearing because it's sharper than it first sounds. The core objection isn't really about the story. Most researchers will grant that the Klamath account is dramatic, that it matches the geology, that the parallels are striking. What they push back on is the verification problem. Oral tradition cannot be independently dated. You can date the ash layer, that's straightforward stratigraphy. You cannot carbon date a sentence. So the match between the account and the eruption, however precise it looks, could in principle be coincidence. Or contamination. European settlers arrived with their own knowledge, maps were made, geological surveys were published, and once that information enters a community's world, it becomes impossible to rule out that later storytellers unconsciously folded it in. The story might be ancient, or it might be a 19th century synthesis wearing older clothes. There's no internal timestamp that distinguishes between those two things. That's a real problem, and dismissing it too quickly is its own kind of error. What the skeptics are right about is the standard. Extraordinary age requires extraordinary evidence. What they sometimes miss is the mechanism question. Because even if this specific case remains contested, the research on how oral memory actually works, the redundancy, the ritual enforcement, the social architecture around transmission, that part is not in dispute. Memory can survive. The argument is about whether this particular memory did. That question, whether this particular memory survived intact, is one the Klamath people themselves have a clear answer to. And their answer is not a claim about geology. It is a claim about relationship. The lake they call Giwas is not a geological curiosity to them. It is a place of profound spiritual significance, and the account of how it came to be is not a story told for entertainment around a fire. It is a history, a record of why the lake is sacred, why it must be approached with care, what obligations the living carry toward it. The eruption and collapse are not the point of the tradition. They are the reason the point exists. That context matters when weighing the contamination argument. The Klamath account was collected by ethnographer Jeremiah Curtin in 1884, decades before systematic geological study of Crater Lake began. The first scientific description of the eruption came from geologist Howell Williams in 1942. The tradition was on paper before the science existed to confirm it, which does not prove ancient origin, but it does cut against the most straightforward contamination story. As for how the Klamath understand the relationship between their account and the scientific findings, most tribal members do not experience that as a verification problem at all. The geology did not make the tradition true. For them, it was always true. The science simply caught up, but the Klamath are not alone in this. Once you accept that oral tradition can carry genuine geological memory across deep time, a pattern starts to emerge from cultures around the world. And it turns out Crater Lake is not the outlier. It may be the most carefully studied example of something far more widespread. Aboriginal Australians hold traditions describing coastlines that no longer exist. Shorelines submerged when sea levels rose at the end of the last ice age, more than 7,000 years ago. Geologists have matched specific accounts to specific underwater features. Volcanic traditions in the Pacific Islands track eruptions that predate European contact by centuries. The Pompeii eruption of 79 CE left records in Roman texts, but oral communities living near active volcanoes in places without written language carried comparable accounts forward through generations. Then there is a case that closes the loop in a way no other does. A Yurok account from the Pacific Northwest describes a catastrophic wave, the sea pulling back, then returning as a wall, on a scale that matches nothing in recent recorded history. But Japanese maritime records from January 1700 document exactly that wave arriving on their coast. Geologists working backward from both sets of records converged on the same night. A Cascadia subduction earthquake, magnitude 9 or above, that struck while no European was present to write it down. The Yurok remembered it. Japan confirmed it. Two independent records, one ocean apart, describing the same event. That is the pattern. Not one culture preserving one memory, but multiple cultures, independently holding geological events that hard science has since corroborated. The mechanism that kept the Klamath account intact appears to be the same one that kept the Yurok account intact. Not accident, but a tradition that treated the memory as something worth keeping. So the Cascadia event is not a curiosity, it is a proof of concept, and it opened a door that a small but growing number of researchers are now walking through. Systematically, with methods borrowed from geology, linguistics, and archaeology at once. The field has a name now: geomythology. The premise is not that all myths are true. It is that some oral traditions encode real events, that the encoding follows patterns, and that if you know what to look for, the signal can be separated from the ritual noise around it. The methods are still being argued over. How do you date a story? How do you distinguish a real geological memory from a metaphor that happens to sound like one? Researchers have developed filters: geographic specificity, physical plausibility, the presence of details that would be irrelevant to invent, independent corroboration from neighboring cultures. None of these are perfect, but they have been enough, in several documented cases, to point geologists toward evidence they had not yet found. The tradition did not confirm the science, it led to it. Which brings the question back to where this video started. Crater Lake is one account, from one people describing one catastrophe. But if the pattern holds, if the same mechanism that preserved Cascadia also preserved Mazama, then what Crater Lake represents is not a single remarkable exception. It is an example of something much larger. And the question geomythology is now asking is exactly that. How large? How large turns out to be a question with a painful answer. Because the same cultures that carried geological memory for millennia were also, in the 19th and 20th centuries, subjected to systematic campaigns to silence them. Languages banned in residential schools, elders forbidden to teach, transmission chains broken in a single generation, the exact chain that had kept Mazama alive across 7,000 years. Linguists estimate that dozens of indigenous languages in North America alone died without documentation during that period. Not declined. Died. The last fluent speaker went, and no one had written down what they knew. Whatever geological memory those languages carried, whatever eruptions, floods, coastline shifts were encoded in their stories, is gone now. Not sleeping, gone. The Klamath account almost joined them. The version that reached researchers survived in part because a small number of ethnographers recorded it before the transmission thinned to almost nothing. Almost. That near miss is the cost of the old assumption, the one that filed indigenous accounts under mythology and moved on. Not a minor academic error, an irreversible one. Every tradition dismissed without examination was a potential data point erased. And unlike a missing core sample, you cannot drill for it again. What fills that silence is the lake itself. Not a metaphor. The actual water, cold and impossibly blue, sitting in the hollow where a mountain used to stand. Hydrologists estimate it loses nearly as much to evaporation and seepage as it gains from rain and snowmelt. The balance is so precise, the water level barely shifts year to year. The mountain's absence has become a kind of permanence. And somewhere in that stillness is the answer to the question this video opened with. How does a memory survive nearly 8,000 years? It doesn't survive as a document. It doesn't survive as a ruin. It survives as a story worth telling, because it was terrifying enough to matter, specific enough to stick, and attached to a place that never let anyone forget something happened there. The hollow in the earth was the mnemonic device, the lake was the proof. Which leaves one question still open. The Klamath account names two specific spirits locked in combat, one commanding from below, one from above, and geologists now read that as a real geophysical detail. The eruption of Mount Mazama was driven by two distinct magma chambers interacting, a feature that only showed up in the ash layer analysis decades after the oral version was first written down. The tradition got the structure right before the instruments did. And that reordering matters, Because it forces a harder question than simply whether oral memory can survive 8,000 years. It asks what kind of information travels most reliably across that span. Not dates, not names, but the felt shape of a catastrophe, the relationship between forces, the thing a witness would need to explain to a child who was not there. Written records preserve the what. The Klamath tradition, it turns out, preserve the why. That is two kinds of knowing, converging.